Hey guys, sorry I'm not in class today, but I thought I would give you a video to maybe help out. We did some of these yesterday. Basically, you're going to put in your 3 squared plus 4 squared equals 5 squared. So you're just choosing a couple of these Pythagorean triples to test. 3 squared is 9, 4 squared is 16, and 5 squared is 25. So that's just proving that 3, 4, and 5 make a right triangle. You can come down here and do a side of 3 and a side of 4, and that would close with a 5. 3, 4, 5 triangle. That's a 5. We can come do another one. Let's do 5, 12, 13. 5 squared plus 12 squared equals 13 squared. So 25 plus 144 equals 196. And that also works because 25 plus 144 equals 169. We can draw that triangle out also to prove it. So we do 5, 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then if we did Pythagorean theorem, we would find that that closes with a 13. And again, that's a right angle with the hypotenuse being the longest side. So then just do a third one over here and draw that same thing in here. Okay. The next slide is just notes. So here you've got your Pythagorean theorem, in case you forget what that is. You've got your sine, cosine, and tangent. This is going to help you find sides, right? And then you've got your trig ratios. So sine is opposite over hypotenuse. So if this is my angle, then opposite over hypotenuse would be 5 over 13. And then cosine of x would be 12 over 13. So that's going to be my 12 because that's the adjacent side. And then the opposite over the adjacent is just 5 over 12. So all I'm doing is taking those trig ratios and putting them into my triangle. Slide number 4 gives us some notes about special right triangles. So we made some, ooh, that's not what I wanted to do. We made some of these into x, 2x, and x on the square root of 3. So opposite the 30 was the x, opposite the 90 degrees was 2x. That hypotenuse is always twice as big as that shortest side. And then you always take the x times the square root of 3 for the side opposite the 60. So this is always the smallest, this is always twice as big, and this is always the small side times the square root of 3. You've got 3 different angles, so you're going to use the square root of 3 for this one. Here we have an isosceles triangle, so the 45s mean that these two legs are exactly the same. So we would have x, x, I've got 2 things that are the same, so we're going to do square root of 2. X times the square root of 2, this is the hypotenuse, right? And those ratios hold true. If I make it twice as big, then it would be 2, 2, and 2 on the square root of 3. Or 2, 4, and 2 on the square root of 3. Oh, that's the square root of 2. I got writing too fast. Square root of 2. I've got 2 angles that are the same, so I've got a square root of 2. I've got 3 angles that are different, so I've got a square root of 3. Those are basically your notes. So then we start in with slide 5, where we actually have to do some stuff. So if I take my 30, 60, 90 triangle, 30, 60, 90, I've got x, 2x, and x on the square root of 3. So x, 2x, and x on the square root of 3. Solve this equation and you get x equals 7. So this side equals 7. So 7 and 14 and 7 on the square root of 3. 7 on the square root of 3. Same thing for the next one, except this is going to be our 45, 45, 90 triangle because it is isosceles. So automatically I know my legs are 8, 8, and 8, because that's x and x. I've got two angles that are the same, so that's x on the square root of 2, which means that's 8 on the square root of 2, or 8 on the square root of 2. If you're not so sure about that, you've got the two legs, so you can also do Pythagorean Theorem. A squared plus b squared equals c squared, where a and b are the legs. So 8 squared plus 8 squared equals c squared. You want to put that into Desmos. So 8 squared plus 8 squared equals 128. Always take the square root. Square root of 128 is 11.3. So over here, this is going to be 11.3. And I can double check that going back in here and doing 8 times the square root of 2, and I get 11.3. Exactly the same. These two things equal each other. So it doesn't matter which number you get, that is all going to work out just perfectly. Let's look at slide number 6. Again, we've got our 30, 60, 90 triangle. So 30, 60, 90, x, 2x, x on the square root of 3. So this equals x. That means 5 on the square root of 3 goes here. This is 10 on the square root of 3, 10 on the square root of 3. And then here we just put in our x, 5 square root of 3, and add another square root of 3 onto it. If you're not sure what that is, just put it in the calculator. 5 square root of 3, and then another square root of 3, and that's going to be 15. The square root of 3 times the square root of 3 cancels out, and you're left with 3. So 5 times 3 is 15, which means this v is going to be 15. Okay, so x, 2x, x on the square root of 3. That's called a reference triangle. It's going to work every single time. With the 45, 45, 90 triangle, we've got two sides that are the same. So we're going to do x, x, and x on the square root of 2. The hypotenuse is always the long side. So this has to be x on the square root of 2. I don't really like dealing with radicals, so I'm just going to divide it in my calculator and get a decimal. So x is going to equal 10 divided by the square root of 2. So 10 divided by square root of 2 is going to be 7.07. So this side is going to be 7.07, and this side is going to be 7.07. 7.07 for both of them, because that's an isosceles right triangle. Two sides are the same and two angles are the same. If you don't like doing those, you can always do them with trig, but this is a much faster way of doing it if you can remember the patterns. We're going to start with this BYX triangle because it tells me y equals 1. So if y equals 1, that's opposite the 30. And that means x equals 2 and b equals the square root of 3 because I've got my 30, 60, 90, x, 2x, x on the square root of 3. That means if this is 2, this is 1, and this is the square root of 3, right? There's a couple of different ways to get the next step. So if I'm looking for 30, 60, 90 triangles and I see 120, automatically in my head, I realize I can cut that in half and make that 60, which means this is 30 and this is 30. And they're going to be symmetrical. So if this is 2, this is also going to be 2. If this is the square root of 3, then this is going to be the square root of 3, and so is this. So if we're looking for b, we've got b, that's the square root of 3. We're looking for x, we got that, that was 2. C is this whole distance, so that's the square root of 3 plus the square root of 3. Square root of 3 plus the square root of 3, or 2 times the square root of 3. You can also find that as a decimal, no big deal. And then A is 2. So I know I've stressed all of you out with this whole 30, 60, 90 nonsense. I've got some isosceles right triangles in question number 6. And you're told that this side is 7, which means automatically you know this side is 7. Good news here, you can use Pythagorean Theorem. A squared plus B squared equals C squared. I know my legs are 7, so 7 squared plus 7 squared equals C squared. So over in my Desmo, I'm going to do 7 squared. Let me get rid of some of these, once you guys have a chance to catch up. So 7 squared and 7 squared is 98. And then I've got to take the square root. Square root of 98 is 9.89 or 9.9. So this is going to be 9.9, which means this other 2 tick mark is also 9.9. I've got 2 new legs. So now 9.9 squared plus 9.9 squared is going to give me C squared. So back to my calculator I go. Can make this into 9.9. Oops, not 0.9, 9.9 plus 9.9 because these are both my legs. .9 squared plus 9.9 squared. I don't know why it doesn't like that. Oh, because I have a comma. Helps. 0.96 or 196. 196.02. We're going to take the square root and we get 14. So we come back over here. I'm going to get a new color. This 3 tick side is 14, which means even though it doesn't look it, this is a 14. So 14 squared plus 14 squared. Again, these are just legs. So super easy. And then, let's see if I can do this right, 14 and 14, that's 392. So A squared plus B squared equals C squared. So C squared, we've got to take the square root of 19.8. 19.8. Question number 8 changes things around a little bit. Okay, so if you don't have a picture, illustrate it. We know when we're talking about cosine, sine, and tangent, we're always talking about right triangles. So ka and toa. So cosine is A over H. A over H. That means cosine of 40. I'm just going to make arbitrarily that one 40. A over H, that means this is A, and H is just 1, because if A over H equals A, then I got to divide by 1, because that's the only thing I can do to not make it any different. So then I come over here, and I've got sine of 50. Well, I know that these acute angles are going to be complementary, so this is going to be 50 degrees. And I know sine is O over H, O over H. This is the O, and this is the H. So A over 1. This cosine of 40 and the sine of 50 are exactly the same. Exactly the same. In question number 8, we're going to do the same thing. It kindly tells us we have a right triangle. One angle measures X, so we're going to make one angle X. I have no idea what the other one is. And then it says tangent of X equals 0.75. Well, I know tangent of any angle should be the fraction O over A, and I know that I can change decimals into fractions. 0.75 is 75 cents or 3/4 of a dollar, literally 3/4 of a dollar. So if this is O and A, and I'm standing on X, the O is here and the A is here. Got a right triangle. I've got two legs. So A squared plus B squared equals C squared. Hopefully we talked enough about Pythagorean theorem and Pythagorean triples that you realize that 3 squared plus 4 squared equals 5 squared. So this is going to be a 5. And then it's asking me ultimately for the cosine of X. Cosine is adjacent over hypotenuse. So if I'm looking at the X, this is the O, this is the A, this is the H. So if I want adjacent over hypotenuse, that fraction is going to be 4/5. Hopefully that makes sense. I'm not going too quickly. Honestly, I'm trying to record this before lunch is over. Question number 9. In a right triangle, ABC. Love it when it tells me exactly what to draw. The measure of C is the 90 degrees. So A, B, and C. A, B and C. AB is 30. If cosine A is 5/6, so cosine is A over H. So A over H. Cosine of A is 5/6. So I can't have 6 equal 30. I've got to kind of make a proportion. I've got a small triangle with a 5 and a 6, and I've got a bigger triangle with a 30. So we've got to make a proportion. 5:6 as X is to 30. So 5:6 as X is to 30. Then you can cross multiply. 30 times 5 equals 6X. So 6X equals 150, and X should equal, I might have to pull out my calculator just to be sure, but I want to say it's 12. No, it's not going to be 12. 5 times 30 divided by 6 is 25. That makes more sense. X equals 25. So this is really 25. So I'm going to have my small numbers inside. That's my trig ratio. And then I just multiplied them basically by 5 in order to get those numbers. What is the length of AC? So my length of AC equals 25. Those trig ratios can get bigger and smaller, just like dilations. If the tangent of X equals M, so again, tangent is TOA, O over A, so I can draw my triangle. This is my X, O over A, and that equals M over 1. So O is M and A is 1. What is sine X in terms of N? So for sine, I need this hypotenuse. So if I know this is M and this is 1, I'm going to do A squared plus B squared equals C squared. Got that hiding down here, right? Let's get a different color. My A is M, so M squared. My B is 1. 1 squared equals C squared. So I'm just going to take the square root of both sides. My H is going to be the square root of M squared plus 1 squared. So when I do sine of X is going to be opposite over hypotenuse. It's going to be M divided by the square root of M squared plus 1 squared. M squared plus 1 squared. I think it's this little guy right here. And again, it's just putting together all of the crazy amount of things that you know about the trig ratios and the right triangles, right? Let's look at slide number 10. Given BC is 5, and the tangent of B, so tangent is O over A, so O is 4 and A is 3, so that checks out. What is the value of sine B? Sine is O over H, and cosine, which is A over H. So O A, and H. Now it's just substitution. O is 4, so 4 over 5. And A is 3, so 3 over 5. When we add those, you're going to add those numerators. So 3 plus 4 is 7, and you're going to keep the denominators. This is just like pizza, right? I love pizza math. I've got 4/5, 1, 2, 3, 4. So I've got 1, 2, 3, 4 pieces of pizza over here. And I've got 3 pieces of pizza over here. 1, 2, 3. They're all still fifths. I just have 1, 2, 3, 4, 5, 6, 7 of them. So 7/5 is my answer. For number 12, you're going to do a very similar thing. And again, you can pause this video as much as you want. Come back to it. Do what you need to do, right? Sine of x equals 0.25. So sine of x is O over H, SOHCAHTOA, O over H. So this is my x, O over H, O over H. And I can change that 0.25 into 1/4. But I know my numerator needs to be 3, so that's not quite jiving with me. So if I put a 3 here, what does my h need to be? Well, 1 times 3 is 3, and 4 times 3 is 12. Or if you cross multiply, 4 times 3 equals 1x. So any which way, this is going to be 12. The length of BC, oh, and that's my answer. Look at that. Love it when a plan comes together. Let's look at slide 11. In the figure below, right triangle ABC is similar to MNO. So this is the small one and this is the big one. With vertices A, B, and C, so A goes with M, and B goes with N, and C goes with O. If tangent of B is 2.4 always over 1, I can always put the over 1. So tangent is O over A. So O is 2.4 and A is 1. What is the value of cosine N? So cosine is going to be hypotenuse and adjacent. So I need to find out that hypotenuse. Can I use Pythagorean theorem there? A squared plus B squared equals C squared. This is my A. This is my B. And this hypotenuse is my C. So 1 squared plus 2.4 squared equals C squared. So I'll go over to my calculator. Handy dandy Desmos. 1 squared plus 2.4 squared is 6.76. And then the square root of 6.76 is going to be 2.6. 2.6. So now I can use my cosine of n. The cosine of n is not going to matter if we use the adjacent and the hypotenuse in the big triangle or the adjacent and the hypotenuse in the little triangle. Cosine of n, because they are similar shapes, is just going to be adjacent over hypotenuse, which is 1 over 2.6. Question 12, right triangle ABC is shown. What is the value of cosine C? So we need to start with what is cosine, right? Cosine adjacent over hypotenuse. Adjacent over hypotenuse. So if this is 12, -3, that means this piece is 12. -3, that means this piece is 3. This piece is 3, and this piece is 5. That means the sides of our triangle are 15. and 8. So if we use Pythagorean Theorem to find h, 8 squared plus 15 squared equals the hypotenuse squared. Come over to our handy dandy Desmo. 8 squared and 15 squared give us 289, and we put in 289 and we get 17. So this hypotenuse is 17. So the cosine of C, we're still on C, is A over H. So the A is the 15 and the H is 17. Cosine of C is 15 over 17. What is the area of an equilateral triangle with a base of 4? So if I have an equilateral triangle, that means all 4 sides are going to be 4, and all of these angles are going to be 60. There is a line of reflection here, so if I cut this in half, all of a sudden I've got a 30, 60, 90 triangle. And if these 2 are cut in half, then that's 2. And now I've got my 30, 60, 90 triangle. 30, 60, 90 triangle. We know the small side and the big side are related. We already have the 2 and the 4. I've got 3 different angles. So we need x on the square root of 3. Or 2 on the square root of 3. So this height is 2 on the square root of 3. Now I want the area. What was the area formula? Oh my gosh. Area formula for a triangle. Area of a triangle is 1/2 the base times the height. So the base is 4. And the height is 2 on the square root of 3. 2 on the square root of 3. So we're just going to put all of that into our calculator. 1 divided by, oops, not minus. 1 divided by 2 times 4 times 2 times, oh my gosh, I'm doing all kinds of craziness because I'm not looking, because I'm trying to rush. Times 4 times 2 on the square root of 3. It's going to be 6.9. So 6.9. But then I've got all of this nonsense. It's not going to be 15. It's not going to be 12. It's probably not going to be 8. So let's check 4 on the square root of 3 and see what we got. 4 times the square root of 3. Those decimals match, so we know we've got our answer. Boom. I think we've got 2 more questions. A certain triangle has a hypotenuse of 2. Hypotenuse of 2, so we're going to draw our triangle. Maybe. If one of the angles is 30 degrees, then the other must be 60 degrees because we know it's right. That means the hypotenuse is 2 and the short side should be 1. What is the area of the triangle? This is the square root of 3. So again, we'll do 1/2 the base times the height. 1/2 the base and the height. So times 1 times the square root of 3. So that's going to be the square root of 3 over 2, because that denominator is going to stay underneath everything. Square root of 3 over 2. In the equation above, the angle measures are in degrees, where m is between 0 and 90. What is the value of m? Cosine of 32. So if this is 32, then this is going to be 58, because those have to be complementary, right? And if this is the O, the A, and the H for the 32, then if I make this 58 pink, that's the O, the A and the H. When I flip between the angles, the O and the A switch. So the hypotenuse is always going to be in the denominator. That means the cosine of 32 equals the sine of 58. So we can just do 58 equals 5m minus 12. And then you solve that by adding 12 to both sides. So 70 equals 5m and m equals 14. It's a tough one. I didn't teach you guys that. In a certain right triangle, the hypotenuse, is that the same exact question? 30 degrees cosine 32, 30 degrees cosine 32. Hey, we don't even need that slide. Let's delete that. All right, that's it, guys. Make sure you do the stacked up trig triangles. Hopefully you're working with a friend, and we'll see you on Friday.